Next thing I notice is, look here, I've got an s squared here and an s squared here. Maybe I should try to combine them somehow. Well, how would I get rid of s squared over here and add it over here? Where I would have to subtract s squared from both sides of the equation. Remember, you can do anything to both sides of the equation as long as you add it to both sides or subtract to both sides or multiply or divide on both sides. As long as you do it to both sides, it's okay. So I'm going to choose to subtract s squared. If I subtract s squared from this side, s squared minus s squared is going to give me a 0. If I subtract s squared from this side, s squared minus s squared is 0. So it goes away. And I've kind of gone out of my way to tell you I'm going to subtract it from both sides, and that's why it goes away. But really, for an equation, if you have the same term on both sides of the equation, it by definition goes away. Because in order to move it over to the other side to add it, you add the opposite. So if I would have subtracted s squared from this side and subtracted s squared from this side, both of those s squares go away. So they end up canceling. So let me rewrite the equation. Negative 3s minus 4 equals, now equal to 5. Look at this. The s squareds just disappear. I want to get s by itself. The next step involved in this is getting rid of this 4. I've got a negative 4 here, so in order to move the 4 over here, I need to add 4. Okay? On the left-hand side, it's going to leave me with negative 3s. Negative 4 plus 4 is 0, so it just goes away on the left. And 5 plus 4 on the right, because I'm adding 4 to both sides, is going to give me 9 on the right. Okay? So I've got negative 3s equals 9. Now the final step in order to get s by itself, I've multiplied s by negative 3 here, is to divide both sides of the equation by negative 3. That's going to make negative 3 divided by 3 is going to disappear because negative 3 divided by negative 3 is going to be 1. Okay? So the answer is going to be s equals 9 divided by negative 3, which is simply negative 3. And that's the answer to the problem. Okay? We're going to do one more problem, and then I'm going to call ourselves done with this section. And this problem is going to look something like this. What if I have x plus 4, x minus 4 equals x minus 2. I'm going to get rid of this little foil sign over here. X plus 2. I'm sorry, I don't want x plus 2 over here. I want x plus 6. So, first thing I need to do is FOIL. So let's do it. X times x is x squared. X times negative 4 is negative 4x. 4 times x is 4x. 4 times negative 4 is negative 16. That's FOIL for the left-hand side. On the right-hand side, x times x is x squared. X times 6 for the outside term is 6x. Negative 2 times x is negative 2x for the inside term, and the last term, negative 2 times 6, is negative 12. Okay? First of all, negative 4x plus 4x is 0, so that just goes away. And also, notice I have an x squared on both sides of the equation. So if I subtract both sides of this equation by x squared, if I subtract x squared from this side and subtract x squared from this side, then both of these x squareds are going to go away. Remember, I told you if you have the same term on both sides of the equation, it just drops out because I can subtract x squared from both sides and it just disappears. So I've dramatically simplified this equation already. I've got negative 16 on the left equals 6x minus 2x minus 12. So I've got negative 16, 6x minus 2x is 4x minus 12. Now I want to move this 12 over here. I want to get this over here by itself. So I'm going to add 12 because I've got a subtraction going on of 12. I want to add 12 to both sides. So negative 16 plus 12 equals 4x. Because the 12 disappears. That's why I'm adding the 12. Negative 12 plus 12 is 0. Negative 16 plus 12 is negative 4 equals 4x. So x, if I divide both sides by 4, is going to be negative 4 divided by 4 is going to be negative 1. And that's pretty much it. This is the same kind of math we've been doing all along for solving equations. The only difference is we've done FOIL in the beginning here. And that about does it for multiplying polynomials.